Welcome to Lesson Up, math tips, tricks, and other ideas. To help continue expanding this site, don't forget to subscribe and like. Basic probability and counting can be cumbersome for some students. We know the math will work, but organizing a problem to fully grasp how to approach solving it, well, it can be tricky. That's why endorsing the use of tools like tree diagrams, sample spaces, and some creative doodling to help in determining outcomes is essential. Consider this scenario. A 6-shooter revolver is a handgun with a rotating cylinder that holds 6 cartridges. Each pull of the trigger rotates the cylinder clockwise, aligning the next chamber with the barrel of the gun. Suppose 3 cartridges are loaded into consecutive chambers of the revolver. The cylinder is then randomly spun once, and the revolver is placed on a table 10 feet from a large target. 2 contestants take turns firing the revolver once at a time at the target, passing the gun back and forth between shots. The first contestant to successfully fire the gun at the target wins a prize. Given this setup, determine whether it is better to be the first shooter or the second shooter if you want to win the prize. If you'd like to try this problem on your own, you should pause this video now. For me, without a doubt, an indispensable tool to help understand what is occurring in a problem is to sketch or doodle a graphic of the scenario. A nice sketch helps focus the mind. I always endorse this to my students. For a problem like this, it gives clarity and a visual understanding of what is occurring. Looking into the cylinder of the revolver, there are 6 empty chambers ready to be loaded with cartridges that can be fired. According to the problem, the cartridges are loaded into consecutive chambers. We can designate the top chamber to be where the hammer of the revolver strikes the cartridge, thus firing the gun. The cylinder is then randomly spun once, clockwise. Now, students often believe that since half the cylinder is loaded with cartridges and the spinning is random, that there is a 50% probability that either of the contestants will be first to fire the gun, thus concluding there is no advantage being the first shooter or the second shooter. Using our graphic, let's take a closer look at this logic. If the cylinder is loaded with 3 cartridges, there are 2 possible ways that the probability of firing first or second is 50%. One of the ways is the cylinder would have to be randomly spun before each time a contestant tries to fire the gun. This process is similar to sampling with replacement. Randomly spinning the cylinder keeps the probability between shooters constant. The other way is the cartridges are loaded into every other chamber rather than consecutively. This leaves each turn of firing the gun equally likely. Well, neither of these situations apply for this scenario, so the probability cannot be 50%. Therefore, one of the contestants has an advantage. We just need to determine which one. The initial spin of the cylinder is similar to spinning a game spinner. According to this spinner, there are 6 different colored wedges where the spinner could stop. The same idea applies to the cylinder of the revolver. There are 6 chambers in which the cylinder could stop spinning. We can easily keep tally whether it is better to be the first shooter or second shooter by scrolling through each chamber of the cylinder. When the cylinder is spun and stops on the chamber shown, the gun will fire for whoever is the first shooter, thus winning the prize. When the cylinder is spun and stops on this chamber, again the gun will fire for whoever is first, thus winning the prize. We can see that the same will occur for the next chamber. However, when the cylinder is spun and stops on this chamber, the gun will not fire because it's empty. The cylinder then automatically advances to the next chamber and the gun is passed to the second shooter. However, the gun will not fire because once more, the chamber is empty. Again, the cylinder automatically advances to the next chamber and the gun is passed back to the first shooter, in which, as we can see, will not fire. The process repeats, in which the gun is passed back to the second shooter, who successfully fires the gun, winning the prize. When the cylinder is spun and stops on this chamber, The gun does not fire for whoever is the first shooter. The cylinder advances, the gun does not fire for the second shooter. The cylinder advances, and the gun fires for the first shooter, again winning the prize. At this point, we could see that the first shooter will successfully fire the gun first in 4 of the sequences. Therefore, if you want to win the prize, it's better to be the first shooter. To determine the probability, we can conclude that if the cylinder lands on this chamber, the second shooter will be first to fire the gun. Thus, we can see that whoever is the first shooter will be first to fire the gun 4 of the 6 sequences, which is 2/3 probability, or about 67% of the time. Now, a fancy animated graphic such as this certainly makes understanding this exercise much easier, but we can't expect our students to go to such lengths to justify their process for solving this problem. And really, it's not necessary. If we let the letter C represent a chamber containing a cartridge, and let the letter E represent an empty chamber, then we can simply express the cylinder using sample spaces. Because there are 6 different ways the cylinder can stop, we can express each sequence of chambers with 6 sample spaces. With this understanding, I challenge my students to this slightly revised problem. The first contestant to successfully fire the gun a total of 2 times at the target wins a prize. If you'd like to try this problem on your own, you should pause this video now. Simply using the sample spaces, passing the gun back and forth, we can see that whoever is the first shooter of this sample space will be first to fire the gun twice, thus winning the prize. Again, passing the gun back and forth, we can see whoever is the second shooter of the next sample space will be the first to fire the gun twice, thus winning the prize. We apply the same process for the next sample space. Here, the first shooter wins the prize. We continue in this fashion, passing the gun back and forth between the first and second shooters for each of the sample spaces. As you can see, each shooter has an equal chance of being first to fire the gun twice, which of course is 50% probability. Thus, for this scenario, neither shooter has the advantage. To help continue expanding this site, don't forget to subscribe and like. Thanks for watching.